Cameras, chicken. Yeah. Right, we apparently are live. Excellent connection. Public. Supposedly live. Where y'all at? There we go. There we go. Kicked in. About time, YouTube. Just woken up the server from like a power nap. Like the server's like, and I'm like, stream. Let's go. Dish out those notifications. There we go. Starting to get some content now. How's it going? Right, let's get this thing off because this is in a couple of parts. We have the whole top assembly, which is an entire board of its own, separated. And then this is a powered mixer. So we have a Class AB amplifier under here. Basically a PA amp underneath a mixing desk. So let's put the top half down there for a minute. And let's have a look at the actual amplifier section, shall we? What's going on, guys? Good to see you. Early today. Yeah, you are early today. What's up from Houston? How's it going? All right, a whole bunch of stuff here that needs to get out of the way. Now, this has been taken apart by somebody else before, just to see what was up with it. So, fortunately, all the bits and bobs do seem to be present. So, yo, Matt, what's going on, buddy? Good to see you. Been a while. That is a massive transformer, given the power ratings of this. I don't think this is like specifically wildly powerful, this amplifier in this mixer, but the transformer is like absolutely packing. I'm sure that this could be could power far more than what's required for this, but there we go. So we've got some heat sinks off already. And this is a Class AB 2-channel amplifier. And we have some damage, gents. We have some damage. So the outputs of this Class AB amplifier, see if we can get a better view with the overhead cam here. So we've got some large, I can't remember exactly the package name for these because I don't come across these super often, but they're like a 247 AC but larger, maybe 2464, I'm not sure. 2SA 1302s are the PNPs, and the NPNs are 2SC 3280, oh no, 3281 by the looks of it. It's kind of hard to make out. So you've got some big package outputs. Emitter resistors here are cooked open as well. And a couple of burnt surface mount resistors by the looks of things as well. So first thing we're going to do is take our multimeter, which needs a new battery, as you can see on the screen there, and see which of these outputs are shorted. Obviously it's going to be probably the ones with the open emitter resistors. So we've got a dead output there, dead output there. So I'm thinking in this instance, it might just be best to go ahead and replace all of the outputs for all of these. We also have another channel over this side that had a burnt emitter over here. We've got actually 150. Yeah, see, that's a little low, 150. So I suspect this one's toast at least, and maybe some more underneath these heat sinks as well. So I think first thing we should do is desolder all of the parts which are suspect. And like I said before, it's probably just going to be a case on this one of just batch replacing everything, all the outputs. Might as well, while we're here. MP, good to catch you streaming again. I really enjoy it. I'm glad, man. I'm glad you enjoy it. It's always fun in games. I try and live stream sort of more interesting stuff these days. Like I've done years and years of streaming the same old amplifiers, you know, that you've seen for a long time. So when I get something in that's a little bit different, I try and jump on stream just for a bit of fun, really. Dr. PC, how's it going, my friend? Mike says this is right up my street. Yeah, something a little different. I don't know what the rail voltages are going to be like on this thing. It's a PA amplifier, so its goal probably is to do power into 8 ohms with a 4 ohm minimum. So it's probably 4 ohm per channel stable with an 8 ohm bridge, I suspect, something like that. So the rail voltages are going to be higher than what you would usually see from a similar powered amplifier from a car that's 1 ohm or 2 ohm stable. Let's have a look. What rating are the rail caps actually? The caps are... Oh hey, the caps aren't actually that high. We only have 80 volt caps, so we're going to have a rail-to-rail potential of 160 volts, which is... it's nothing really compared to some of the stuff we're used to working on. So yeah, pretty low rails, so this isn't going to be wildly powerful. And now for something completely different. That's right. Let's get the big soldering iron turned on in preparation, because we're going to need it for taking these out. I haven't actually looked yet to see whether there's a service manual or schematic on this model. It's a pretty simple Class AB, so I doubt we're going to need any documentation to assist us with this, but you never know. We might need to find out the value of one of the surface mount resistors that's burnt that we can see. But given this is a 2-channel, I'm hoping that the burnt surface mount on one of the channels is readable on the other channel. Alright, that should be that heatsink off as well. We've got a couple of little, got a couple of voltage regs, a couple of voltage regulators that are clamped to this heatsink as well. Got a 7815 and a 7915 for the auxiliary rails, for the preamplifier stage, etc. I suspect. Now, what kind of fitment are you? Let's see whether I have a tool to get you out of here. I think I should have, here we go, this should do the job, either this or the bigger one. Okay, the bigger brother of that should do the job. That's smaller. There we go. That's the one. Right, awesome, there we go. 1, 2, 3, 4. The emitter resistors are in a different orientation on these other ones here. Okay, so as we know, let's start making a list of parts that we're going to need for this thing. So open up the old notepad. We are going to need 2SA 1302 or similar or equivalent. We're going to need 2SC 3281 or equivalent, and we're going to need how many? Well, there's 16 total, so we're going to need 8 of each. Times 8. Now, emitter resistors. What value are the emitter resistors? They're not your normal kind of looking resistors. They're these kind of wire wound things that are coated. And I don't see any markings on any of them. There'll be super low resistance, like sub-ohm. So I don't know whether we're going to get a reading from the multimeter. Now, if I do my test lead resistance, we've got 0.4, 0.5 ohms of test lead resistance. I'm just going to scoot that back and forward a little bit to clean up the contacts, see if we can just get it stable. So yeah, on the verge of 0.4, 0.5. So if I read across one of these emitter resistors that hopefully has survived. Okay, so we have 0.7, and together we have 0.4 or 0.5. So I'm going to call it 0.5 because it's just on the limit. So it's going to be 0.2 ohms going by that. Now, if we can find a schematic or if we can see any marking that any of these have to confirm that, that would be useful. But going by this, it's either 0.2 or 0.15 on the emitter resistor. It sort of goes to 0.8 just at the end there. Yeah. So I do have an ESR meter. So what I will do is probably remove one of them and drop it in this. But I don't know how much I trust this either for like super accurate readings of resistance, because it's a cheap ESR meter. I use it for confirming that transistors, MOSFETs, etc. are well matched for HFE and VT, CG, etc. So in addition to the dead outputs and the emitters, got a bunch of surface mount components here that look okay. There is one surface mount part that I spotted over here, which is bad. I'm not sure how well you can see that. R140. So just whilst we've got the multimeter, let's see if we can find that same resistor on the other channel, because it's a 2-channel amplifier, so it will have a basically mirrored circuit. So so we have a sort of 131 across that. Now that resistance isn't necessarily going to be reliable because obviously there are shorted components over here, so we could be reading a short through something else. But what's it connected to? Is it connected to any of the outputs here? Okay, so it's connected to the emitter resistors here. So obviously the emitter resistors are all paralleled together, and then we've got this big diode here. So we have that resistor connected to all of the emitter resistors, and on the other side, where does that go? Okay, it goes to pin 1, which is I think going to be the base in this case. Doesn't go to pin 1, it goes to pin 1 of the PNPs. Pin one of the PNPs. Okay. So let's see if we can find that same resistor over here on the other side. So we're looking for a resistor that is connected to all of the emitters. So like here, for example, we are covered in thermal paste, which is kind of annoying because it's kind of hard to see. Okay, here we go. We have a resistor here, which is a 150 ohm. Which is connected to the emitter. And then the other side should be connected to the base. Yeah, there we go. So that's our resistor value, 150 ohms on the burnt one that is illegible on the worst channel here. So that's cool. Excellent. Excelente. So the only thing we don't know for sure is the value of the emitter resistors because they don't seem to have any markings on them. But we have measured with the basic multimeter. It's about 0.2 ohms. Well, we can drop one in the ESR in a minute. We have our soldering iron probably up to temperature now, so let's go ahead and drop these parts out of here. Evening Yalon, how's it going, my friend? Let's grab some more solder. Flood this a little bit. Now, this is kind of old, so I assume that this is probably using leaded solder on the board here. It looks pretty fresh still, so I suspect so. Lead-free kind of goes a bit dry looking over time. Now these are heavy, so they should just drop out, I hope. Not quite drop out, but almost. There we go. So they're not going to be quite drop out because they are quite tight in the holes there. Evening too fast. How's your evening going? Or afternoon, whatever time it is where you are. Now I hope these parts aren't going to be too expensive. So this isn't really a customer repair, this is more like a repair for a friend. Just get that all cooked and flooded. I'm going to go ahead and remove all of the outputs from both channels because I want to confirm that they're all okay, and it'll be good to just replace all of them. We have 8 of each type, I think. Yeah, 8 of each type, so 16 in total. Not too bad, provided they're not like £7 each. Norway. Oh, it's 8:30 in the evening. Nice. I've been at the vet with my dog. Everything's good. I'm glad to hear it. Repair for a friend. Friend equals wine drinking. Well, we drink Ribena on these streams, my friend, to appease the algorithm. I'll tell you what, it gets absolutely roasty toasty in the workshop with the door closed and all the lights on like this. I'll just quickly crack the window. Gets roasting in here. I have been, guys. I've been so busy. The amount of repairs coming in recently, I can't believe it. It's unreal. There we go. Window has been officially cracked open. It's always relaxing to actually work on these amps, so I'm glad to hear it. It's like, I imagine it might be kind of ASMR-y or just like kind of relaxing for some people. So 1, 2, 3, 4 have been removed from that channel. So now we've just got to take these ones out as well. This thermal paste is very old. Transistor erection. Man, I need to send you some of my repairs. Timbo, how backed up are you? What's your turnaround time at the moment on repairs? So because the UK isn't super big of audio scene, the audio scene is not that big in the UK. I'm pretty much the only guy doing like the kind of Class D large scale amp repairs. And when I get busy, my turnaround time at its most is usually like 4 to 6 weeks, which for me is kind of long. And you know, clients here in the UK tend to think that's quite long. But I have spoken to some repair techs in the States, and they have like 6-month turnarounds. So it makes mine look quite small and maybe not quite as busy. The thing is though, if your turnaround time is getting to like 6 months or whatever, surely that must mean that the repairs are coming in quicker than you can repair them. So it's just going to stack up and up and up and up and up, and you're going to end up with like, you know, it's going to just be continuously getting longer. So how do you work that out? Do you like turn down some repairs and just take on the sort of most profitable ones, or the biggest ones, or the smaller ones, or how do you manage that? I'm on the laptop now. Even if they're £7 a pop, they're next to no one around here that repairs this sort of stuff, except a few shops, but the price they charge is insane. Yeah, so as a shop, you know, to make this profitable, you do have to charge kind of wild. I try to, because the audio scene isn't that big here in the UK, and my kind of take on it is that some money is better than no money, and this is kind of still a hobby for me. Like, even though I've been doing this for so long, what feels like so long now, I get great satisfaction from doing this. It's like a game. It feels like a game doing repairs and stuff like this. So if what my point is that if I have to charge like much lower than I otherwise would like to, or like a relatively low hourly rate on something, just so that I get to fix it and I get some money thrown my way, then yeah,